if they write, if they write 1 mole, that's different. If they write 1 m, this means 1 molar solution. This means 1 mole of substance. So this is of some substance, this is of a solution. Now that means it will also have water. That means this is concentration actually. So this is a number, this is a concentration. And 1 mole means 1 mole of, he says, is it of hydroxide? Hydroxide. So that means then you visualize in your mind immediately 1 mole of NaOH in 1 liter of solution. So actually this means 1 mole per dm cube or 1 dm cube. So this actually means. So now the question says ki, you have to again visualize whatever is happening. Huh? So don't just go by the maths or the chemistry. So you say I have got 4 gram by so we titration, na? What's titration? So it's like they take something in the burette and then they that is long pipe kind of thing, and there's a flask, a conical flask, and what they do is they neutralize each other by drop something comes and neutralizes. So he says he takes 4 gram of uh, titration is just reacting to things exactly with nothing in excess. Okay, but in solutions, and in solution you have to find you'll be given the concentration or the volume, and then you find the moles, and then you look at the equation to see the mole ratio, then you find the other so it's like this. So here notice he's given you 4 grams of aspirin, right? So he what he does is he says, okay, the mr of aspirin is so much, and he's also given you the NaOH volume and the molarity. So that means how many so he takes, like when I told you this is 1 molar, this is 1 mole, this got 1 mole in 1 dm cube, okay? One. So if you're taking only 25, if you're taking only, oh sorry, 17.5, if you're taking only 17.5, obviously the number of moles will won't be 1 mole, because 1 mole is present in 1 dm cube. So the number of moles in this much volume will be uh, moles per volume is concentration. Okay, so moles in is equal to volume into concentration. So that means 17.5 centimeter cube in dm cube in this and into 1. So that's what he does. These many moles he's got. So basically he's multiplied concentration into volume to get the number of moles. Okay. Now he goes to the equation. Now he goes to the equation. He says, uh, 1 mole requires 1 mole, right? So 1 mole of NaMO consumes 1 mole. So that means 0.75 will consume 0.175. So he says, okay, so I think 0.175 moles of CH. But then he says 0.75. I've got the number of I've got the number of moles. I've got the MR. So I'll get the weight. So weight over MR is equal to number of moles. So then he multiplies the MR into number of moles, and then he's got 0.175 into 180, and this many grams is the weight, the mass. But he had said he had to taken 4 grams. So essentially what happened was he had taken 4 grams, but only when he calculated the NaOH coming, that the amount of moles, this 0.175 neutralized 0.175, and that is corresponds to 3.15, whatever, 3.15, and actually it took 4. So naturally, the remaining part, that means 0.85, is impurity. So that's what he's doing. He's saying 3.35 into 100. This is what he does. So basically, you you're given the volume and the molarity or concentration, of NaOH. You come to know the moles of NaOH. You react it, and from the mole ratio of the reaction, you know the moles of aspirin. And if you know the moles of aspirin, and because you know the MR of aspirin, you get the mass of aspirin, and then you compare it with the, this is the reaction mass according to reaction, actual mass, and then you can get the purity.